Hi, my name is Nicole Snyder, and I'm going to tell you today about the project that I worked on for our course, WebGIS. The title of my project is Wastewater Respiratory Virus Tracker, and I figured I would present this to you today in the form of an ArcGIS story map, since that was one of the elements of the course, and I think it's just a really nice way to present this data. I'd like to begin just by telling you a little about the motivation for the project, and then we're going to hop into the dashboard visualizations that I've created as part of the program. The abstract is here, and I know that many of you have likely already seen this on our course board, so I won't go through the abstract line by line. But the idea here is that, I was really interested in trying to develop new visualizations to present wastewater data. And the reason for that is that I work as an epidemiologist for the North Carolina Wastewater Monitoring Network, which is part of the North Carolina Department of Health and Human Services. And wastewater monitoring really took off during the COVID-19 pandemic. But since then, we've added a number of other respiratory viruses and other pathogens to our wastewater sampling. And, they're just thinking about different ways to really present this data in meaningful ways for the stakeholders that use the data has become something that I'm really interested in. And I will say that we do currently have methods to visualize the data here in North Carolina. This is done through Tableau, but there are a lot of limitations there. And I just thought, with all of the tools that we learned in the course, that I could really take, what I know our community members are looking for, and the knowledge that I've gained to try to put something together that would be a little bit more engaging, for our community. And so that's what I'm hoping to present to you today. So the dashboard really starts by talking a little about wastewater monitoring in North Carolina. And that's where I'm going to start my story today. SARS-CoV-2, flu A, and RSV are currently being monitored twice per week at 35 sites across the state of North Carolina. Those samples are collected as 24-hour composites on site at a wastewater treatment plant. And then those samples are shipped to either the State Lab for Public Health, which is sampling 29 sites, or a CDC contractor known as Verily, which is monitoring 6 sites. Now, these samples are filtered, analyzed, and then that data comes to me. And it's my job to take that data and do some math with it. I normalize it by flow rate. I also normalize it by the population that is known to be living within the sewer shed that contributes to the wastewater treatment plant. And then I report that information to the CDC and use it to generate a number of visualizations at the state level. I included this visualization that we put together at the Department of Health and Human Services to really help the readers here understand the process so that they get a sense of what wastewater monitoring looks like. And although this visualization was created during the COVID-19 pandemic, it could easily be adapted to many of the other respiratory viruses and other pathogens that we're sampling. So after that short overview, the idea is to just hop right into the wastewater dashboard. And I wanted to note that for this dashboard, I'm only presenting 29 of the 35 sites across North Carolina. The reason that I chose to do that is because those are the sites that we're sampling for at the State Lab for Public Health. And it's just right now that data is something that I had on hand, was more readily, easily used to generate the visualizations that are here. But one thing that I would hope to do is to go back and incorporate those other sites, that are part of our network. So the data that I'm presenting are for 3 pathogens, SARS-CoV-2, flu A, and RSV at all 29 sites. And it's important to note that we sample those sites 2 times per week at each site. And those sampling dates can really vary just depending upon who's at the wastewater treatment plant doing the sampling that week. And so one of the things that I did that we normally don't do was spend some time really cleaning the data and aggregating the data so that I could average those 2 data points that we're picking up each week to create an average value at each site per week. And so what you're going to see reported on the wastewater dashboard, which we're coming to, is the average viral particle copies per person per liter reported by week ending. And this is aggregated, for those multiple samplings per week. Just to give an overview of how I set this up, I did provide a little sidecar here that talks about different ways to engage, right? So selecting a pathogen, and a date to view the different metrics for each one of these pathogens, being able to use the tables and also, some of the other charts that are here to look at different elements of the data to try to get a better picture of both the overall state, but perhaps, the region that the stakeholder might be living in. And I also put some information here about a way that a user could engage. One of the things that I really wanted to incorporate, and I was inspired by Flu Near You, was this opportunity to embed a community respiratory reporting tool where individuals could go in and report their infection status. And so we'll talk a little bit about that. So the dashboard is here. There's also, and I'm going to come back to the dashboard, but I wanted to just, scroll down to some other elements that are here on the storyboard. So there's an opportunity to use this QR code for reporting. Of course, you can access the survey, the survey 123, right through the dashboard itself. But I just felt like this was another opportunity to engage the community. And then here I've included the required project details. I won't go through these, step by step here, but those details are here from how, I manage the layers and data sources, to my data collection methods, to how I pre-process the data and then publish layers and services, and then also kind of the steps that I used to work through the dashboard and the storyboard. I've also included some references, just a general reference if you want to learn more about wastewater surveillance for viral pathogens, and then also the references for my data sources and some of the shapefiles that I used. Okay, so with that, I do want to go back up and spend some time because the primary goal of this was to generate this dashboard. And I will say that, there is one limitation here with story maps, and that it's the dashboards don't always view as nicely as they do if you just open them. But the one really nice thing about the story maps is that it does allow you to actually enhance the dashboard. So we're going to click on this and open it live and access it that way. Okay, so while this is opening, what I want to do is kind of talk you through the features that are here, why I chose to incorporate the features that are incorporated, and then just kind of leave it for you to be able to, engage with. And so the first thing that I'll point out is that I added a header. This header up here is the title for the dashboard, Wastewater Respiratory Virus Tracker. And you'll also see that there's two options, one to select a pathogen and one to select a date. And again, keeping in mind that the data is being reported aggregated by week. So the first thing that I want to say is that by changing these, it's going to change the visualizations that you see on the left. So the map will change, the table will change, and the pie chart will change. And we'll look at how that happens here in just a moment. But I wanted to just kind of sit with this particular visualization first to kind of walk you through the different features. So the first thing that you're going to see at the very top is a map. In that map, we're reporting our pathogen levels by site. So these are our average viral particles per person per liter of wastewater by week ending. And you can see that the different colors here visualize the different levels. Now, one thing that you would need to be able to understand that is a legend. And so that's actually incorporated through this drop-down menu that says More Tools. And if we click over, we can see here that we have a search option. We have a legend option, and I'll click on that one now just so we can see that legend. So that's there. The layers can be changed here. And there's also base maps that can be changed here if the user would like to do this. There's a zoom feature that's down here, so it allows the user to zoom in and zoom out. And then there's some other tools that are here as well. So there's a ruler, right? You can do some measuring if you would like, and I can just click over so you can see that measure distance and measure area tools. And then there's also over here a ruler just to give you a sense of the distance. The other thing about this is that these all of these different sewer sheds that are here are active, so you can actually click on them, and I'm going to do that in real time, and hopefully it works. It is a little bit slow and lagging, but you can see the site, you can see the county, the population, the week ending that's being represented, right? The pathogen that's being represented, and then the viral copies per person, which is really helpful. And then in this case, right, you can also, if you want, click on these counties, but for the sake of time, we won't do that. Okay, if we look down here at the bottom left, right, there's a table that provides the top sites by average viral particles per person. I thought this is really interesting because, it's one thing to look at the colors on the map, but it's another thing to actually see this in tabular format. And this does allow the user to then scroll down and look at each one of the different sites that's reporting. Notice if a site is not reporting that week, it's gray on the map and there's no values in the viral particles per person category. Okay, there's a second visualization over here, which is a pie chart. One of the things that I really felt would be helpful here is that these sewer sheds are representing, specific regions around these wastewater treatment plants, where the wastewater treatment plant is collecting wastewater. And so in this case, the sewer shed is just representing a portion of a population, that generally falls within a larger geographic area. And one of those geographic areas are the counties. So there's a county layer that's up here on the map. And I felt it might be helpful to be able to show if we were to break this down, what that viral particle burden percent would be if we looked at it at the county level. And the reason that I chose to do this is that, even though we're just maybe even looking at a very small part of a county, we've done some really nice studies where we've shown that these sewer sheds can be highly representative of what's occurring at the county level. And so, maybe you're not represented within the sewer shed, but you see your county down here and you can say, oh, okay, it looks like, I'm living in Mecklenburg. So, right now Mecklenburg has, essentially the lion's share of the viral particles that are being reported to the state. And what's really nice here is that if I click on this, it'll actually highlight the sewer sheds that are in the map, right? And I could zoom in on those if I would like. And then it also, takes the table and really restricts to those sites that are represented, within the county of Mecklenburg. And so we see these here, again, ranged by highest to lowest in terms of the number of viral particles per person. Okay, so I want to just take a minute to show, how these features then change when I change pathogens. I'm actually gonna, before I switch to the pathogen, I'm actually gonna switch the date because we're kind of at the end of respiratory season here, and so a lot of these levels are really low. I'm going to go back to when the levels were a little bit higher back in January. And so now you can see there's some significant changes here, right? Lots of red, right, which is higher. If we go back to, for example, our legend, right, we're seeing those higher levels of viral copies per person within those different sewer sheds. And so in this case, this gives us a better view. And we're also going to see now more flu and RSV, which is a little bit more difficult to detect, and those seasons ends a little bit earlier. SARS-CoV-2 persists in wastewater throughout the year, but that's not the case for flu and RSV. So then if I click on, for example, flu, it's going to change, and now we'll be able to see the data, for flu. And if I click again and switch for RSV, it's going to change, and you're going to see the data for RSV. And notice that in all of these cases, right, you can see that the map changes, but also the table changes, as does this pie chart. We see that season ending a lot earlier with RSV this year, so not a whole lot of data to report here for RSV. But if I go back to flu, right, we can see that, again, we've changed our pie chart and our table to match, and then back to SARS-CoV-2, and it's going to change again. Okay, so I really felt like this was a really helpful way for a community member to be able to visualize these pathogens side by side using these different widgets. Okay, on the left, I'm kind of excited about this. This would be the North Carolina Community Respiratory Reporting Tool. So this would allow community members to really provide their data. And the way that I chose to do this, there were two ways that I could have done this. I wanted to collect more than just maybe points on a map. I wanted to associate data with those points. So I chose to go the survey 1, 2, 3 route. I created a survey called North Carolina Community Respiratory Illness Report. And if you look at this community respiratory illness report, we can just kind of scroll down. It gives individuals the opportunity to enter their name or just write anonymous if they're not comfortable with that, right? There's a place for a last name and a first name. Their age, right? So choosing their age range is helpful for information we might want to collect. Infection type, right? So what type of infection might they be experiencing, right? Or think they might be experiencing. The report date, which automatically populates just based on when they're reporting the symptom onset date, which, is again proximate based on their experience, whether or not they were tested and whether or not that test was positive. So yes or no, right? Positive test date, and then a place where they can add the location. And we're pretty clear about, you don't have to provide a specific address. You can, get closest street or city. It's just good to have this data to be able to compare it to what we're finding, in the wastewater. And then there's a map that they can use. And for this, I actually was able to incorporate a North Carolina-based geocoder. So it's a little bit more precise. And then what's really cool about this is that it populates this table in real time. So it's responsive, and it allows somebody to see their data. So I know I'm getting close to time, but I figured I'd just kind of fill one out for you, just to give you a sense. So let's say that John Smith wants to fill this out. And let's say that John is 65 and older. He believes he has a SARS-CoV-2 infection. And in this particular case, his symptom onset was a few days ago. So we can look at that here and just kind of scroll up so we can see the rest of that map. So we'll say the second. And then as we scroll down, he did not have a positive test. He's just, testing. This is just what he believes based on his symptoms. It's not known that he didn't have a positive test. So in this case, we just can leave that blank. John's not really comfortable with, really leaving his address, but he lives in Chapel Hill. So he's going to type in Chapel Hill, North Carolina, right? You can see that responsiveness there. That's going to zoom in, right? And then John's going to click. I think I mixed it there. Real time. Okay, so, and then that's set. He's going to say, the reason I think I had COVID is because I lost my sense of smell and taste. And then he can click submit. And it takes a moment, but then we should see, eventually here a dot that pops up here in the, essentially outside that Chapel Hill region. It may have to refresh here. There it goes. So now we can see that dot. And the one thing that I wanted to use the survey 1, 2, 3 for was because I can actually click on these dots now and look at the different data that's there. So if I click on that dot, I can see that a person who's 65 years of age or older is reporting with SARS-CoV-2 with some additional information. And I can see a lot of that information that was typed in here. Okay. Now, notice I did take the name away, and I put that up here and note that, even if they report their name, it won't appear, right? We would collect that data, but it's just not something that's going to appear in that pop-up. So I'm really excited about this. I mean, it's just it's really kind of a demo for now, but I think it has real use, and I think it takes a little bit more time in building it out and thinking through some things. And even as I'm working with you and talking with you, through this presentation, I can see some things that I might want to fix or make a bit cleaner or clearer. For example, I could replace this inline survey with the QR code so that somebody could do this on their phone. There's a lot of different things to think about, but I just thought this was a really good example of the power of all of the skills that we learned, to be able to put this to use for something that I could actually use at the community level. Okay, so just going back to the storyboard, I just want to finish off by talking a little bit about, some of the challenges that I had, with putting the project together. And so it was fairly straightforward to put the layers and data sources together. The layers were either available or had access to the data through my role with the North Carolina Wastewater Monitoring Network. And so this data collection method was also pretty straightforward. I think the one thing that was really challenging was the pre-processing of the data. I had to do a lot of data cleaning. The file that we take down from the One CDC platform after I've uploaded it contains over 200 columns and 100,000 rows. So I had to do a lot of data cleaning and aggregation. And I did this work partly in SAS using some code that we'd established to do the preliminary cleaning, and then in R for a lot of the aggregation and reorganization work. Um, Another challenge that I had was when I was working with the data initially in ArcGIS Pro, I was having a lot of trouble getting the data to join, and quickly learned that I had to put everything into a geodatabase if I wanted to do a one-to-many join rather than a one-to-one join, which is what I was continually getting. So, that was something else that was really one of those things that takes 10 seconds once you learn it, but took about an hour before I figured it out, reading lots and lots and lots of blogs. The publishing, because I had a lot of data, even this data set is about 9,000 rows. It just took some time. But at the end of the day, this went relatively smoothly. And the dashboard and storyboard development was relatively straightforward once I got everything together. So with that, I really hope that this is, interesting to you and gives you a sense. And, maybe in the next year or so, I can put something together that I can actually use at the community level. And so I just want to thank you very much, for your time. And please let me know if you have any questions about my wastewater respiratory virus tracker. All right. Thank you very much. And I look forward to your comments. Take care. Bye-bye.